Hello and welcome to the lecture. I know there were issues last time with some of the figures not showing on the video, so I'm going to start this lecture by going over the last few minutes of the last video and show you again the information I had about the figures. So let's get started. Let me go to the screen here. And now you're seeing the script that we went over last time, where we have plotted the power, AC power, instantaneous power, and we also calculated the average power given some parameters, right? And then this resulted in a plot, which is the one that I was going over with you and showing you some of the things you can do with plots. And so let me run the script and then I'll continue discussing that. Okay. So if you remember the information we enter in here in the script is the frequency, the voltage amplitude, the current amplitude, and the angles or the phase angle for both current and voltage, and that's it. And then we're looking at the instantaneous power and the average power, right? So we're going to enter a radiant frequency of 377 radians per second, a voltage magnitude of 4 volts. We're going to choose an amplitude or a magnitude for current of 2 amps, and a phase voltage for of 45 degrees, and a current phase of 60 degrees. And first of all, you can see the results here, or I should say the end result of the average power. And these are the parameters we enter. And we could have, remember, well, there's a lot of things we can do here. We could have formatted this a little better by, actually saying what this is. This is the voltage amplitude. This is the current amplitude or magnitude, and so forth, right? The theta V, theta I, and then the average power. And as we get into more of formatting plots and formatting outputs, we'll look into some more features of that. But for now, we're just showing the end result, right? And the average power here in watts. All right, so let's see. So now let me briefly go, and now you'll be able to see the plot and what I was trying to do last time. So okay, so now you're seeing the actual plot, right? Which you weren't able to see it last time. And here, again, we're just doing a quick plot here, just to show you some of the major features of plotting. And a lot of what I'm going to tell you here, you could do within the script or within the code, where you can format what you want to see and how you want to see it, including like things like the color of the different plots and the information you want to see on the screen, the axis information and so forth. All of that can be done from within the code by using different plot commands. And so later on, we'll see how to do that from within the code. But for now, what I wanted to show you is that you're able now to manipulate this plot. Because if you want to save it, or if you want to print it, or put it in a report or something, you can at this point manipulate it and change some of the things that you want. And for instance, if I go on File, if I go Edit and look at the axis properties here, Hold on a minute. What happens here is that every time the screen changes, I have to share it again, and it's that's the issue here. So okay, there you go. So you're seeing this again. When I went into edit and chose access properties, right? So when you do that, when you also can look at figure properties. But in here, you can start changing things if you want. You can, first of all, you notice that this figure doesn't have a name, but I can give it a name. Figure 1, you can call it, I don't know, script 1 or something like that. And that will be the name of your file, okay? And you can see once I enter it, it's going to change it from that figure 1 default. So now it says figure 1, related to script 1 or whatever name you want to give it, right? If you now go into edit and select access properties, then I can then start looking at things like, well, maybe the title of the plot, I want to indicate what that is. Power, that'll be the title. You can also change the axis information for X, Y, like X, for instance, has no, put the label, for example, for Y, if I want to say parameters, then you can see that that shows up here. You can change the font that you want. If you click on any of the plots, like in this instance, I'm plotting on each one of those here. I can, if I double click on any one of them, I can display what that indicates. So because of the values I gave to the parameters, I know that that's voltage. So that's going to be voltage. And so this, this value here is not going to be associated with a voltage. And I can also change the colors if I want, associated with that plot. Okay. I can also then go back and choose, let's say, the current. Okay. And double click on current. I can change the name associated with it if I wanted to. Current. Change the color if I wanted to. All right, let's make it green. And you can change the type of line that you want, so forth. Like if I want dotted lines or something like that, you can start seeing the difference, and you can start customizing your plot. Really nice, right? I can also, look at all the information I have related to the plot. If I do more properties, and close that. You can zoom in, zoom out. If I click on zoom, you can start zooming in. You can also use your scroll on the mouse to do that. All right. And if I say I want to see a specific value or area, I can move it and move to that point. And if I want to see, for instance, what this intersection point is, if you click on this area here and then select the point, I can then see exactly what those points are. I can choose any point I want on the plot. Okay. And then scroll if I want. If I want to go back, I can just zoom back in. If I want to get rid of this information, I can right click on it and you can see it says delete current data tip. If I delete it, it'll just get rid of it. I can always bring it back by clicking here and selecting whatever point I want. Okay. I can also select what information to put on the legend. See, before, remember, I gave the name voltage and current. And now I have a display here, you know, to indicate in the figure exactly what that is. So that's very useful. I can go back to the power one, see how the power really hasn't been labeled. I can change the label. I can put power. Okay, and now you see that that information is going to be displayed associated with power. I can again, if I want, change the color for power. Okay, and you know now it displays exactly what it is. So again, this gives you information that you can change on the spot. If you look on under insert, you can, you know, change information, add information. If I wanna, for instance, if I wanna highlight something, like I wanna highlight, you know, some information here, I can use that test um, from insert, you know, the arrow test. I can put a text box around that and, you know, put something here that will be important for your, you know, whatever you want to put in there for your plot. And, you know, in other words, you keep adding information very easily, right? And so at the end, you can save this plot, you know, save as, or you can also generate code that you can then use within MATLAB to regenerate this plot again, which is also very nice, right? And see right now is taking information, and as you can see, well, let's see if you can see this now. Let me make sure we're sharing this again. Because remember, each time I change figures, I gotta reshare again. So let's see. Yeah, I think you're seeing this now. And when I chose to generate the code based on all the changes I made, see, it generated the code automatically. Isn't it nice? See? And it also shows you how you can then manipulate the code to regenerate the plot. So I have the plot open here. I'm going to close it. You're not seeing that probably, but I'm going to close the previous plot I have. And now I'm going to run this untitled. It's going to ask me to save it. So as you can see, I'm going to give it a test plot name just to save it. And if you run that plot, that script, it should get regenerate the plot, but it needs data. And so far, since I haven't provided the data, then it's not able to generate it. But it's something we're going to get into later in the semester, how to manipulate these figures. But that's what I wanted to show you last time, that once you generate a plot, you can change it, you can manipulate it. You can also do it from the code itself, but if you don't, you can add things, you can annotate, you know, add things that you want to add later to make it more clear. Also, another thing I wanted to show you is if you look at let's see, we should have a voltage. Let's see. If you click on any of the variables, right? We have. Let's see. Let me regenerate the. I'll run the script again. I'll give it different numbers just to. Okay. And so now again, if you notice on your variables, right? V has is our voltage, is a variable for the voltage. I is the variable for the current and so forth. if I choose that, see, if I go to plots, you look at this tab that says plots, okay? If I select plot, okay, I can then, let me clear that again here. If I choose V, for example, I can plot that voltage, see, right, by itself. If I just want it later to do that. If I do let's see, you probably didn't see that because I wasn't sharing it. Let me share it again. What it does is, and you can see it now, when, see this plot right here? It was generated on the spot. Let me go back and show you again. Okay, and what I did was, remember, I went to the plot tab, selected plot, and just click on the variable I wanted to plot. So that's another thing you can do on the spot. All right, that's all that we missed last time from the previous lecture. So I want to continue with the rest of the lecture by talking about some more array manipulation, some more vector manipulation, and some more matrices manipulations that we need to understand in order to do more interesting things. Okay, so let me just stop for a minute. All right, so I want to continue with some of the things that we were talking about previously about vector manipulation, array manipulation, matrix manipulation, and maybe refresh a little bit about the things we have been discussing. So you're seeing my screen right now. So now recall from the previous lecture that the way we can access information from an array, or the way we can generate an array, is by once we get the array name, by giving it or choosing a first term, the spaces between the terms of the elements, and what the last element is going to be like. For example, we did things like, if we have, let's say you have, let me define just a simple array here. Just 97 minus 3 and 0.5. Use this as an example. Okay. So I have an array with 5 elements in it, right? If you remember, I can also generate a array like y equals, and then I can choose the first term. So if the first term is 5, and then I'm going to do the spacing like every 5 of them, and I want to generate up to 50 as the last element. Okay. And as you can see, I have the first element is 5. The increment, right, or the spacing between those numbers is also 5. So 5, 10, 15, and so forth, up to 50, right? That's the formatting, right? The first one, the first element, the spacing between elements, and the last value of that element. Also remember that I can look at the length of that array by simply using the length command, and that will tell me the length of the array, which in this case for x is 5, right? 5 elements in it. Later we're gonna see how these numbers are formatting right now in scientific notation. Later we'll see how we can change that to show any way you want and many other ways you want. We'll see that in a little bit. And the other one that you can use is the size, right? If I use size x, then I'll see the actual size, a vector 1 row 5 columns, right? And that's you know, some of the information we've done before. If I want to select an element within that array, I can just type that element. So the second element in this case, as you can see, is 7. If I type n, remember n will give me or show me the last element in the array, right? What else? If I do x n minus 2, for instance, it'll show you the second element, previously or from the n, right? So this is the first one. This is the n element, n minus 1, n minus 2, right, and so forth. So that's how you can manipulate how to access information related to these arrays. Some of the other things you can do, for instance, now that if you know the length, or if the length is implied in the statement, right? If I do, for instance, x length x, oops, sorry, I do this too fast, and I'm missing a parenthesis. Okay, now I can see that it shows me the length. It shows me the last element because the length of the array in this case is 7. So it really showed me the last element in the array, right? Which in this case is 500 e to the minus 3. Okay. So that's the format. That's something that if you recall we did last time. And this, if you remember, there's more than one way to get the information that you want, right? Not just this way. For instance, if I do, let me do y this time. Y has 7 columns right in it. We have 7 elements. It's a 1 by 7 array. So if I do, if I want to look at the specific elements in an array, if I do, for example, x and target the elements 1, 2, and 4 in that array, then you can see that I have 5, right? 5 is the first element. 10 is the second element, which is the one I was interested in. And the fourth element is 20, right? So by doing this type of manipulation, right, if I enclose in brackets, right, because ultimately that's what I want to get to those elements in that array, I can enclose them in parentheses, but the brackets indicate what elements I'm interested in. So all kinds of information that you can do to access elements in an array. Okay. Another example, just to play with this a little more. If I do, what do you think doing n? Oh, let me type x again to see what we want, what we have, right? That's what we have originally with x. So if I do x and I go from n, and in this case, I do a minus 2, and hopefully you remember what the minus 2 will indicate, to 1. What do you think that will give you, right? So you're looking at beginning at n, right? You remember what that is the first element. You increment by a factor of minus 2 up to 1. So the step is minus 2. So if I run this little line, what do you think you will see as the answer? All right, so I'm gonna give you a minute. You can pause it and then look at it. So you see that in this case, I got the elements display starts with the n element, which in this case is 50, and then it goes down 2, and then gives me 9, and then goes 2 more, and then it gives me 1. Right. So all sorts of manipulation. Let's look at another one. What do you think? looking at the same array, what do you think this one will do? Okay, right. Well, hopefully this will be a little more obvious because, well, would it? Will we have enough numbers to give us what we want? So what do you think this will give you given this array, right? Well, if you run it, you'll see that, it's going to start again at n, right, which is this one. Then it's going to go down 3, right, and that's it. Because it can't go down anymore, right? That's all the elements you have. So in this case, it displays 2 elements from the back, 3 steps more towards the front of the array. Okay, let's do another one, and in this case, let's change the numbers of x to have, let's see, 9. Let's do -5, 7, 2, 4, and 9 again, and that's our new array. Okay, and then so now we have 7 elements, right? 1, 2, 3, 4, 5, 6, 7. I'm sorry, 8 elements, right, in the array. 1 by 8. So, if I do, for example, if I do this now, starting at 2, with an increment of 2 to the n, okay, what do you think that will give me? Okay, well, give me a minute. As you can see now, it starts at element number 2, right, which in this case is 8. It's going to go 2 elements again to -5 in this case, 2 more elements, and 2 more elements because you reach the end. Now, what if instead now I do the same command, but now I'm going to assign it 4. I'm going to assign the number 4 like that. Okay, what do you think will happen? Well, as you can see, it assigned, if you look at the original x, right, this is x. And now what it did was, this is the original x that we have, right? So now what it did that is that every element, right, starting from the second one in increments of 2, was substituted by that number 4, see? So the second element was substituted by 4, the fourth element was substituted by 4, the sixth element by 4, and the eighth element by 4. Okay? That's another way of manipulating changes in arrays, right? Very efficient way of doing it. We could have also do it with a for loop if you wanted to replace numbers, but this is a more efficient way of doing steps like that. Okay. All right. All right. So you remember the last thing we did was when we were looking at manipulating arrays. If I let me just I generated a new X array, right? And you can see now those are the numbers that the array has. And of course, things like size will tell me the information about the array. So 1 by 9, 1 row, 9 columns. And if you remember last time we did this bit here in order to change the numbers in the array so that every second number is replaced by 4, right? So doing this, the second number is replaced by 4, then the fourth one by 4, the sixth, the eighth, right, and until the end. So let me bring X again and show you another way of doing using a for loop. So let me bring the original X. Okay, so that's what we have for X right now, the original X. And if I want to use a for loop for also getting the same result, one way of doing that is using the length command. So in that case, I'm going to start the index at 2. I'm going to increment the index by 2 again until I reach the n, which in this case will be the length of the vector. And so I'm going to assign every ith element that is defined by that index. I'm going to assign the value of 4, and I'm going to end that. And if I look at X now, you know, this is what I'm going to have. This was the original X before I enter this little for loop. And now again, every second element is being substituted by the number 4. Other examples. What if you want to, for example, replace the last 5 numbers in X? Let's do this. What if you want to replace the last in the array X with the number 2? So how would you try that? Okay, just give you a minute. You want to pause it, right? So we want to replace the last 5 numbers in X with the number 2. And by the way, again, remember, there's not a single way of doing this. There's more than one way of doing that kind of thing. But one way will be you can use the n if you want, right? If I enclose in brackets and start from, you know, the last, the n minus 4, n minus 3, which might not be the most elegant way of doing it, until I reach n. That's my last element, right? And then the last 5 numbers, right? Because if you look at this vector, you know, I'm choosing the number, the last element up to 4 elements before that, and I'm going to assign the number 2. And so as you can see, the last elements of the array X have now been assigned the number 2. A more efficient way could be to do something like this, right? If you start from the element before last, which in this case is n minus 4 to the n, which is basically, if you look at this, is exactly the same thing as doing this. It's just using this shortcut method, right? Because I start at n minus 4, and I'm going to end at n, which is the last one. And again, I'm going to assign the number 2, and the result is the same, right? So what if you want to replace now? Let's want to replace same thing, but this time the first 3 numbers with a minus 5. So now you're going to replace the first 3 numbers, and let me go bring the original X again, the one I had originally. So that's the one we want to replace, right? We want to replace the first 3 numbers with a minus 5. So I'll give you a minute, and then you can see that one quick way of doing it will be just to start from the first one up to the first one in the index, and then assign minus 5 to that. And you can see that excuse me, the first 3 numbers here are being substituted by a minus 5. Okay, give you another one. This time replace the last 4 numbers in the array with the first 4. Let's see, do we have that's fine. And let me just bring the original X again so that we can actually see the end result. So we want to replace the last 4 numbers here with the first 4 numbers here. Okay, so how would you do that? Okay, you want to replace the last 4 numbers with the first 4 numbers. Well, again, not one single way. So if you've done it some other ways, you can test it and see if it works, and that's fine. But this is one possible solution. Will be to again look at the index starting from n minus 3 to n, and then swap that because I want to go from 1 up to 4, right? So I'm assigning the first 4 that I have here to the last 4 that I have here, right? And as you can see, this swap was made, right? Okay. So this is replace the last, actually it's not a swap, I'm just replacing the last 4 numbers with the first 4. It wasn't a swap, I'm just replacing those 4 last numbers here with this one actually, because that's the last array I had. The last 4 numbers, including that 4, were replaced by this first numbers here, right? And that's what I got. Okay. And this worked because both of the arrays are the same size. So if we go back and now use the array again, and let me just okay, more manipulations that you can do. For example, let me modify the array X, and this time I'm going to have 1, 2, 8, and let's add 10 to it. And so I have 4 numbers in the array, and then I want to replace the first and the third elements with 2 new numbers. Okay, so I want to replace the first element and the third element with new numbers. Okay, I want to put something new. So one way you can do this again is by choosing the index, right? So I'm going to go to the first and the third one. Okay, that's choosing those 2. Yeah, in fact, if you run that command, it shows you that this is the first and the third element. So now I'm choosing the first and the third element, and I want to replace it by some number that I want. I don't know, minus 11 and 55, right? So now, as you can see, the original array, first 2 numbers, the first number was replaced by minus 11, and the third one was replaced by 55. Okay. Now, what if you want to replace the first and third elements with 2 new random numbers between 3 and 5? All right, so let's try that. Replace first 3 elements. You want to replace the first 3 elements let's try this one instead. Let's replace the first and third element. You want to replace the first and the third element in the array X, which we have already, with 2 random numbers between, let's choose 3 and 5. Okay, so we want to replace the first and the third element with two random numbers between 3 and 5. And before I do this, let me show you a couple of ways to do things like that. One example, for instance, is if you run the random number function, if I just do this without any numbers in the parentheses, what it's actually doing, that function is just generating one random number, right? By doing it that way, it just generates one random number. That's it. Remember, if I put elements in it, okay, if I do, for example, 1, 5, if I do that, then it generates, 5 random numbers, right? As you can see here, right? 1, 2, 3, 4, 5. So going back to our task here, I want to, so doing that, let me show you. So if you want to generate a number between, and this is just for one number, between some range, right? Let's say it's a, let's assume the first number is, so I'm going to generate numbers between 1, I'm going to assign A1, B10, right? So what I'm going to do right now is I want to generate, and I'll go back to this task in just a minute, but I just want to show you some of the things you can do with a random function. So if I want to assign A equals 1, B equals 10, that's going to be my range where I want the number to vary. It's going to vary between 1 and 10. So in this case, I want to generate one random number, just one random number that's going to be between these two numbers, between 1 and 10. And let me just give it, assign the variable x, okay? So what I can do is I can take the minimum, which is A, subtract the two minimum and maximum, and I'm going to multiply by the random number generated, in the function. If I do that, as you can see, I've generated a number, one single number, random number, between 1 and 10. If I run this again, it's always going to give me a number between 1 and 10. Random number between 1 and 10, right? Any random number. Okay, so let me clear this. So going back to the random function, what if instead of generating one random number between 1 and 10, now I want to generate n numbers between 1 and 10? Well, since, as you remember, doing this, right, generates 5 random numbers, I can use that from what I used before, but instead, in the argument within parentheses, the extremes is still 1 and 10, right? The numbers generated will be between 1 and 10. But this time I want to generate, I don't know, 5 numbers, right? So this will give me 5 numbers between 1 and 10, random, right? And you can see the numbers don't exceed 10 and they don't go lower than 1. If I run it again, oops, I erased something. Yeah, I added something. Okay. If I run it again, you can see, right, it generates numbers between 5 numbers between 9 and 10. If I want to change it to 10 numbers between 1 and 10, right? Okay, so that's a quick way of using the random function to do things like that. So going back to our task, now that you know that, okay, I want to replace, let me clear this, you can see that mess. Okay. So I want to replace the first and the third elements of the X array. We can bring back the X array. I only have 5 elements, so let me just reassign numbers to this array. All right. So now I have enough numbers, you know, to replace the first and third elements with 2 random numbers between 3 and 5, right? So one way you can do this is using the same concept that we used before. So my target is the first and the third element, which again, if I type this in, you'll see that I'm looking, you know, this statement or this line says that I'm looking at the first and the third element, right? So if I use that, then now I'm going to assign it a random number. And this time I want a random number between 3 and 5, so I can use, you know, same concept that I used before. I'm going to multiply times 2 the random number that I'm generated between the 2 random numbers between 1 and 3, and I'm going to add 3 to that. And so now I have substituted the first and the third element by 2 random numbers. Okay, the first and the third element by 2 random numbers. So I run that again. I'm going to get 2 new random numbers, right? The first and the third, and the other ones obviously don't change. Okay. All right. Some more manipulations. What now if I want to add the first 3 elements? So I want to add the first 3 elements to the last 3 elements in the array. And I just want to save them somewhere. So I want to add the first 3 elements. And so what I have so far in the last X array is this. So I want to add the first 3 elements, this one, to the last 3, and I want to save it in some variable. So I want to give that a shot. Close it, and then I'll show you the solution. One possible solution, I'm going to assign it to a variable z. I'm going to take the first 3 elements, and I'm going to add that to the last 3, right? So the last 3 could be from n minus 2 to n. And let's see if everything is correct. Of course, I'm using an x. And let's see, that should be a plus, right? Because I'm adding the elements, not an equal. Okay, so I can make that correction. And as you can see now, I added the first 3 elements of the array to the last 3 elements of the array, right? 12 plus 4.42 is 16.42. 17 plus 5 is 22, and 10 plus 3.44 is 13.44, right? So that's a quick, neat way of manipulating. And of course, you can spend hours and hours doing all these kinds of manipulations, and what you need to do is practice and make sure you're understanding how this is happening, right? But you know, but it's just showing you the possibilities here. So let's just look a little more about more manipulating arrays. For example, creating a vector with constant spacing and creating a vector with linear equal space. And if you remember, if we want to create a vector with a with a certain numbers in it that we want to have, and with a certain space in between, we can use the linspace function, right? And remember, if you ever need help on any of these functions, you just type the name of the function, help preceding it, and you will see help associated with it. And in this case, if you look at the linspace function, it's going to generate n elements, right? N points between these two numbers, or all space linearly. Okay, just a row of vectors. For instance, if you want to create a vector with linear spaces, you specify the first and the last term and the number of terms, right? First and last term and the number of terms you have. So, for example, if I do x 2, 10, 9, what do you think that will give you? And I'm going to assign this to linspace. So I'm going to assign it to a variable, and I'm going to space it linearly like that. And instead of using x, I'm just going to space it linearly, right? So what do you think this will give you? Right? Let's see if you were right. Well, you have how many numbers? 9, right? 1, 2, 3, 4. Well, you can see the size of y if you want to count. We have 9 elements, right? Which is what we wanted. We wanted 9 elements from 2 to 10 spaced equally. Right? So 2 to 10. Let's change that to look at the same features. This time I'm going to start at 10, 1, 12 numbers, but I want to go from 10 to, I don't know, up to 100. So let's see. So what do you think that will give you? Remember, you're going to start at 10, right? So you start at 10, and then this is linearly spaced, right? But since you want 12 elements, right? Okay. Again, if you look at the size of y, you have 12 elements, right? So that's what you wanted in y. And you start at 10, but you want to go up to 100 in equally spaced numbers, right? So all these numbers are equally spaced, see? Right? So the way you're going to get to 112 steps is by having all those increments. Okay? One last one. Let's try this one. So what do you think? So now let's say I want to start from 25, and I want to go up to 30, I think, and I want 10 numbers, right? So then obviously you're going to start 25. The last number you're going to see is 30 in this case, but then we want to have a space, or rather 10 numbers for that result. So again, I have 10 numbers, and in the space that I have given it, is going to go from 25 to 30 in giving this result. Okay. All right. Now, notice the difference if I do this, for example, right? If I assign x equals, and I'm going to do from 2 to 10, and this is x, right? A new variable. So if I do this, it's just going linearly from 2 to 10, right? Because in this case, I don't have any increment, right? If I put an increment in between, let's just say it's 2, then it's just going to go in 2s from 2 to 10 in steps of 2. Here, if I don't put a number. It just goes from 2 to 10 in steps of 1, because the 1 is by default. Okay. If I omit the number of elements using linspace, then it's going to automatically generate 100 elements. So if I do, going back to linspace, let me choose one like that. Oops, I want to run it. So if I choose this one, but I omit the 9 and I leave it just like that. So if I omit the number of elements, then it's going to generate 100 numbers, or 100 the elements that go from 2 to 10. And you can see here, right, 100 elements. And if you want to double, so it tells you right here it goes through 100. But if you want to check, it's a, why do we use? Yes, so it's 100, right? It generated 100 numbers from 2 to 10 because I omitted the number of elements at the end. Well, also quickly, if you remember the scripts, right? If we want to, not the script, the subscripts, it's very important what they, how to access specific numbers, right? So if we look, for example, let's say I want to generate 5 random numbers, and I'm going to assign it to the variable Q. So Q has 5 random numbers. Remember very easily, if I want to access the third element in that array, I just put 3 in parentheses. If I want to access the elements from the third one to the fifth one, and again, very easy, I can do that, right? From the third one to the fifth one in this case, right? But what if I want to remove elements from the array? Let's say I want to remove, instead of, how I can see this give me the elements from third to the fifth. But what if I want to remove those elements, right? So if I do that, if I assign an empty bracket, now I remove the last 3 elements from this array. I only had the first 2. So doing this removes elements in the array. Let me go back to my original queue again. And this time I want to make, instead of removing the elements 3 to 5, I want to make them 0. So if I do this, and instead of having an empty bracket, I can put whatever number I want, and I'm going to make it 0 in this case. So now I replaced the last 3 numbers by 0. I can choose any number. 1, I'm going to replace it by 1. I replace the last 3 elements in that array by 1. Okay, that's another way of manipulating arrays with subscripts, using subscripts. Okay. One more thing before we move on, talk about formatting. You know how the numbers show up, and like in this case, see how you have 4 decimal places. You can choose to select how you want to display that information, like if you want it in exponential, or scientific notation, or if you want engineering notation, and so forth. And there are many ways of formatting the data you're going to see. But the 2 more common ones are, if I use format short E, it's going to display the information in scientific notation, with E meaning short, sorry, meaning 5 significant digits. So this will be 5 significant digits. If I do the format as, instead of short, if I do long, E means E is going to give you an information in scientific notation. This is going to display 15 significant digits instead of 5. If I do format the same way, short, but this time instead of E, I use E and G, it's going to give me the information in engineering notation. Same for short. It's a short format with 5 significant digits, but the information will be in engineering notation, will be displayed. If I do G instead of all the other ones, MATLAB is going to choose it. MATLAB is going to decide if it's going to give you a fixed length or a floating point result. If you use RAT, R-A-T, like this, you're going to display the information as a rational number. And there are more of those, okay? But for our purposes right now, those are the ones that we're going to be using more often, especially engineering notation. So let me just show you a few examples. Now, anytime you type a format, the information you're going to see, whether you use it on the command line or you're using the script, is going to be using that format that you've chosen. It's not going to change until you change the format to something else, okay? So if I initially type format short E, everything else that follows is going to follow that scientific notation with 5 significant digits or significant digits. So if I then change it to long E, then at that point it's going to pick up on that new format and display that information using that format. So anytime you want to change it, just type the format that you want. So let's look at one example here. Since I have RAT as the last one, that one is supposed to show me the information as a rational number, right? So, could be useful for many cases. So if I type, for example, pi over 2, then you see that it shows it as a fraction, right? If I type, I don't know, 9 into, well, that may not be a good rational number, but 3 into 9, right? You see 1/3, right? If you type 234 divided by 98, I don't know. You see the information as a rational number. If I change to, let me change to short, and if I type pi over 2 again, then it's going to show me the information as a scientific notation number with 5 significant digits. If I change that to long, or the format to long, it's still a scientific notation. And if I type pi over 2 again, then you can see that still scientific notation, but now it's displaying 15 significant digits. Now I'm going to choose short engineering, which should give me 5 significant digits. And I'm going to type pi over 2 again. But since it's a number, doesn't really have 10 to the 0 is still scientific notation, right? So let's use a different number. Let's type pi over 0.02. Let's type something that will give us, how about pi over 200. And now you can see it's 15.708 times 10 to the minus 3, right? Science, engineering notation. So anything that I do at this point will be in scientific notation, right? If I change it to, and that was short, so if I do long engineering, now I'm going to change the format to long engineering. If I use, again, pi over 200, it's still the same number, but with more digits tied to the result, okay? So that's how you use formatting, right? There's more ways of formatting numbers, but this is, one immediate way that you can do it. Also, if I want, let's say, if I want to do x equal pi over 200, but I just want to see the integer portion of it, I can do something like this. And if I didn't assign pi over 200 to anything, so I'm going to have to retype it. But if I do this, then all I can see is the integer portion of that result. And the 8 just means that it's going to give me eight bits of information. I can change, if I change that to a 16, it's going to give me the answer with 16 bits of information. Now let me choose something that is actually has an integer that is not 0. If I do over 2, then it's just going to display 2, right? It's approximating that to an integer with 16 bits of information, right? So that's can you also get results just with integer information in it. Let's do another one. What if we have integer and I want to divide, if we have 2 times pi over, so 2 times pi over 2, yeah, that's fine, right? Because if you remember, 2 times pi is 6.28. If you divide by 2, then you're going to get something that approximates 3, right? 6.28 divided by 2 is over 3. But since I'm typing this as I want it as an integer, it's just, giving me the integer portion rounded up to 3. Okay? So that's how you use formatting. One more thing, if you remember, we also talked last time about the for statement. And the format of the for statement is you have an index, and you have statements after that index, and then you have the end statement, right? So for example, if I want to display, let's say I want to display 10 random numbers, and just 10 random numbers. I'm gonna let the system display just 10 random numbers, right? So I wanna use a for statement for that. So an easy way to do that is just to do, with the index, obviously it's gonna go from 1 to 10, right? And then my case statement or my statement is just to display a random number, just one random number, right? So that's all I want. I want to display one random number, and that's it. I'm going to end the for statement. So as you can see, what it does is it does 10 iterations, right? The first time displays just one random number, and then it does it 10 continuous time, right? So the use of the for statement, as you remember from last time, is just a for statement with an index, a statement or group of statements, right? Because I can do something else here also if I wanted to, and then end the result. Well, let's say, for example, now I want to display just 5 numbers. I can change this to just go every instead of 2, right? And then I'm going to do the same thing. I'm going to display the random number, and I'm going to end it, but this time I have just 5, right? Because I'm stepping, every 2, right? So every second iteration, I'm going to generate a random number, as you can see. The other one that we need to understand and that we used briefly last time, but it's just like in many or any computer language, if you program before, is the same idea, is the if statement. So the if statement follows an if condition, then a statement or group of statements, and then the end. We also have the if else, or the if else if statements, and we're going to use some of those as we go forward to write scripts and to do computer more programming, more coding. One more thing I want to mention is some of the logical operations that could be useful. The ampersand indicates and, the logic and. The bar indicates or, and the wiggly character indicates not. Okay, those are three of the ones that we can use among other ones, but those are the most common ones, right? So we have and is the ampersand, then we have or, just a bar, and then the approximate symbol or the wiggly symbol is the not or negation. Okay, so we can use that for, in many cases, we're going to use it at the bit level, but you can also use it to manipulate some of the vectors of the matrices. For example, I had, what if I generate a vector that has the following numbers? Okay, just, just those numbers. Okay. And what if I want to display all the values that are less than 5? So all values less than 5 in one single statement. Of course, there are at least a few ways you can do this. You can use a for statement or an if statement to dig into the matrix or the vector and extract the information you want. But if we use some of the logic operators and also some of the math operations, if I do this, if I do SA, which is the matrix less than 10, and given what I have in this matrix or this vector, right, you can see is displaying, is showing me the places in the vector where the elements are less than 10. So in this case, it's the first element because that is true, the second one, and the third one, right? Give you another example. What if I do elements less than 5? So what do you think that will display? That's only showing me the logical places with a 1 where that information is true. So if I do less than 5, it's only one element less than 5, right? Which is this one. And it shows me where that element is. It doesn't show me the actual element. It's just telling me where that element is. What if I do elements greater than 10? Well, you can start figuring that out, right? It will be, given our matrix, it'll be, where's the matrix? The vector. It'll be these two, right? These two are greater than 10, 11 and 20. So it shows me the one before last and the last, right? With the ones. So what do you think, given that information, what do you think this will do? Okay. Right, what do you think that will do? Because now remember, this right here is what I just did here, right? Elements greater than 10, right? Elements greater than 10. So this one is picking up the location, right? So as you can probably imagine, oops, sorry about that. There's a missing parenthesis. Hold on, I'm missing something here. Oh, I don't need a parenthesis, I'm sorry. I had an extra parenthesis. There you go. It's only one. Sorry about that. So what that will do is actually showing me the values, right, that this matrix had where the elements exceed 10, right? So in this case, as you remember, for A, right, we have 11 and 20 as the last two elements. So it's showing me here the elements greater than 10, right? Now this statement just physically tells me, well, logically, I guess, tells me by displaying a 1 where those numbers greater than 10 are. But this one is actually choosing those elements, see? Right? Now I can also combine with the logic that I mentioned before. I can combine some of those operators, right? Let's say I want to display all values less than 10 and greater than 5. Okay, so I want to display, looking at this matrix or vector A, not a matrix, well, it's a 1 by 5 matrix vector. Given this vector, I want to display all values less than 10 and greater than 5. Again, I can use some for statement, if statement, a little script, but doing it this way, you'll see is a way more efficient. So if I do a combination of what I did before, like if I do A less than 10, it's showing me the numbers, all the values less than 10. But if I also combine it with the AND statement, right, where I want all the values greater than 5, then that statement is combining with the AND information, is a logical information, and it's showing me where that result is located, right? It's showing me all the numbers from this vector that satisfy that condition, that the numbers are less than 10, right, but greater than 5. So as you can see, that's the only number that satisfies that condition. Let's just change. Let's add more numbers here that could satisfy that condition. 8. We want numbers less than 10, but greater than 5, right? So let's add another one over here to start, right? So now we have a new array, right? And this new array has these values in it, and I want to repeat the statement with the logical operators. So now you see I have elements that satisfy this condition. Element 1, right, is less than 10, but no greater than in less than 5. I have, well, of course, 9, which I had before, and then I also have 8, right? So I have all those 3 elements, right? See how I'm able to select that, right? What if I want all the numbers not equal to let's see, not equal to 20, right? So if I do A, and I'm going to use this not operator, not equal 20, see, it shows me the places where the numbers not equal to 20 happen, right? And as you can see from this vector, the only number that is 20 is the last one. So the last one appears as a 0, right? So so that's one way for for you to figure out a quick shortcut for manipulating vectors like that. All right, that's all I have for today. We'll see you in the next lecture.